say, learning in progress. And then this
Wait, what range again? Range. Quadrant. Oh. Why did you do that?
Yes. And so wait,
The range is the same as the domain.
it's like range.
You ready to go? No, for this, it's gonna be negative.
If you imagine a normal spectrum, and then range for the inverse. So the domain of regular side.
I'll give you another 15 seconds or so.
It's all.
That's the
Yeah, all that. Except the end. So the sign is the range is negative one plus on the range.
Oh, the range is negative.
Wait, is there a why is it? Oh, yeah. Sorry, I did it wrong.
Okay, folks. Go ahead and finish up your conversation. Okay, let's hear from Elle. Can you tell us about sine inverse, please? Yeah. Yeah, the domain. Okay. Okay. Well, did you get the range?
Well, would the range be 1 to 1?
Yes, it would be negative 1 to 1 if we're talking about. Okay. Okay. Are we good with that?
No. That's you.
Any questions? So, you started with the sine and then you went to the inverse of that. So, okay. So if I were to draw a picture of it, it would be this, wouldn't it?
Okay, what is frozen?
Oh, it is frozen. Thank you. So negative 1 to 1 and then negative infinity to positive infinity. Are we good with that?
Wait. I think it's negative 1 to 1.
For the domain?
And then range,
Ah,
it's gotta be. Wait, I feel like the range is negative 1 to 1 and we flip it and the domain.
is it?
So, I know,
Yeah, Augie?
wait, because this doesn't pass the vertical line test. So
It
you
quite
have to-
fails it.
You have to restrict the range to like, negative pi over 2 to pi over 2.
So right here, this area right there?
Yeah,
Yeah, that is what I'm looking for. So the range is from negative pi over 2 to pi over 2.
Okay.
Anything else? Does that ring a bell?
but that makes sense. Top finance.
Okay. We just started. It's okay. Yeah, so this graph for y equals sine inverse of x is basically a sine wave creeping up the y-axis, except we can't use all of it. So we just use this much. And we have negative 1 to 1 for domain and negative pi over 2 to pi over 2. Would everyone please show me the quadrants this is associated with? Quadrants 1 and 4. Quadrants 1 and 4. Oh, that's such a bad 4. I need to redo it. That's all bad. 1 and 4. There we go. Elle, thanks for your help. Cosine inverse. Max, can you help us out? Find the domain, range, and the quadrants.
Okay. I think that the domain is the same.
Okay.
So negative 1 to 1. And the range, this time, it's gotta be 0 to pi over 2. I don't know. I'm a little stumped.
Okay. What do you guys think?
Uh,
Pi?
I think it's 0 to pi.
0 to pi?
Oh, because you add an extra half of pi over 2. Oh, okay. Oh,
Well, this is just if we're going to do y equals cosine inverse. That's a piece of the cosine that is going up the y-axis. So we just take a look and say, when does it stop passing that vertical line test, right?
right there.
Right there. I see you pointed directly at it with your chin. It was perfect. And right there is the y value of pi. That's where we're going. That is the range. So it looks something like that. Jonas, did you have a what's that?
No.
Okay, yeah, this is the answer. And would you please show me the quadrants that it's associated with? 1 and 2. 1 and 2.
Mr. Lindgren, I have a question.
Ask me the question.
Why is sine inverse of x 1 and 4 when like the line goes through?
It does seem like it's 1 and 3, doesn't it?
Yeah.
Oh, maybe I just made a mistake. Anyone have insight into that? Or could you please discuss with your neighbor? Why are we talking about sine inverse in quadrant 4? How does that work? How does that relate to this graph?
Oh, it's because of that. Here's here. And so those the places where places that you're pulling. Okay, like that, like side. And then the flipping it to negative pi over two. Looks like this.
Okay, so what's the connection? What is the connection? Yeah, how does it relate to 4 instead of 3? Yes, Connor for 200.
Going the circle counterclockwise, like how the quadrants go.
Mhm.
4 and then 1 is
Oh,
two.
counterclockwise.
It goes from negative to positive.
So if you're going counterclockwise like this way,
Yeah,
then that would be, what were you saying about this? I'm sorry.
well, the quadrant 4 and then quadrant 1
Okay.
is where it goes from negative y values to
Mhm.
positive y values.
Okay, so oh, the y values, thank you. Yeah, so if we're looking at the y values here, then we have quadrant 4 and quadrant 1. Okay, nice.
But then can't you do 2 and 3?
Yeah, can we do 2 and 3?
Oh, because we always start at positive.
Yeah, we want to keep 0 in the window that we're looking. And also this right here, that's 0 to negative pi over 2. I hope that makes sense that correlates on the unit circle to here, doesn't it? Isn't that 0 to negative pi over 2?
Oh, yeah.
It's the fourth quadrant, like directly related to that fourth quadrant. And that 0 to pi over 2 is right up here. So anytime you're looking for an angle for a sine inverse, you look right at the first and the fourth quadrant. Going from the 0 to. Good question, Max. Thanks for asking. Tan inverse. Jonas, help us with this. Do you know the domain and range for it?
Isn't it? A little bit. Is the tan, is the domain -1 to 1?
Good question. Is it -1 to 1?
No.
I think it's negative.
Hmm. You're close. Negative infinity to infinity? Is that what it is?
Because you have flipped the asymptote from.
No, it is negative.
Oh,
Yeah, it kind of helps to think about the graph of tan inverse of x, where the vertical asymptotes from tangent become horizontal asymptotes. And then inside it looks like, show it with your finger marker.
Negative.
Yeah, so something like this. Yeah, so
The range would be negative, negative pi over 2 to pi over 2. Non-inclusive.
not inclusive or exclusive. And the quadrants,
1 and 4.
1 and 4, just like sine inverse. Any questions? Please remember during the warm-up, and I'll get your question. During the warm-up, I expect you to be focused. And if you're not sure how to do something, I expect you to ask, starting with your partner. So I gave you a lot of time. There should be no waffling on this stuff. Please. Oh, so Emma, you had a question?
But like I sort of memorized like the part that the fourth sheet gave us about like the unit circle highlighted.
This one?
Yeah.
Oh, that's nice.
Look at that to figure out the domain of the range.
Uh,
It doesn't exactly correspond to it. Is that because like that will go back to or what's the reason why?
exactly. This is an illustration of where the action is happening for these, but it's not really a graph of like any of these functions. It's just saying where the activity is. But this is a really good way to remember everything, isn't it? That sine inverse and the tan inverse. It's over there. It's in quadrants 1 and 4. Cosine inverse, it's up there in quadrants 1 and 2. So you don't have to remember from the graphs.
The range is what the range is gonna be higher.
Well, it's tough from here because we're not looking at the sine wave, we're not looking at the cosine wave, and that's where we would really see the flip. So here we're just showing like kind of like this is brain activity for a sine inverse. It's happening over there. That's where the action is. And I really appreciate your clarification question. So nicely framed too. Thank you. Okay, sine inverse of -3/2. I'd like to hear about that from the one and only Leah. Leah with an L.
We got that is negative pi over 3.
Okay, do we agree with Leah? And Simran, apparently. Can you explain how you got that?
Got that because there's like the sine quadrants are 1 and 4.
Okay.
And then to get like the y value to be negative √3/2 as being quadrant 4. And then you can't like go around, so you have to like go like the negative way, so that it's negative pi over 3.
We're good with that?
Not too.
That was nice. Yeah, Simran?
I agree with her.
Uh-huh.
Also, could you just because this is in quadrant 4, could you say 5
Well, let's take a look at sine inverse graph. Right, it doesn't go up, it just goes up to pi over 2, and then we have to go back into it. We have to back up. I think for this one, it would be, stop. It'd be like right here, right? It's just before that negative pi over 2.
Yeah.
Good question. Are you able to show me cosine inverse of 0, everybody? Can you show me this? No, you can't show me that. It's too hard. It's too hard. You're like, how many fingers must I break for this one? No, 0 is the answer. Una, can you help us with cosine cosine inverse of 0? Uh-huh.
When the like x and 0, and since it's like the quadrants 1 and 2, it's up here, so pi over 2.
So this is like 0, 1. Is that clear? And you didn't want to use the one down here because that I know that's also equal to 0. Yeah, cosine inverse doesn't happen down there. It's only happening up top. That's the only answer. Yeah? Gut. Thank you, Una. Guten Tag. We almost have a conversation going. Miley, help us with tan inverse of 1. Okay, where did that come from? Okay.
Then if we find out √2.
Sounds reasonable to me. Are you guys okay with that?
Yeah. Yeah.
Oh, any other ways to think about it? What,
No.
or what?
No.
What's the word you're saying? Slope. Remember, tangent of an angle could be thought of as slope.
Oh my gosh, I see the correlation.
You see it?
Oh,
So remember, this is saying, when you see this inverse, this is talking about the angle whose tangent is 1. Do you see that slope action happening here?
I do.
Right, the tangent of pi over 4 is 1. We see that slope is 1. Not only up there, but also down here, but it's tan inverse. So we're not going down into quadrant 3, not for tan inverse. I hope it's all coming together okay. If not, better figure it out because next time we quiz. Next time we quiz. Next time. Sorry, not this time. You got excited, I saw, but nope. Next time. Sorry. I know. I'm like a quiz tease. Okay.
You had those candy beans.
The baked beans?
No, it's like these.
Oh, it's like it tastes like.
Some are like good flavors, some are like.
I always get booze.
That's so evil.
It's so bad.
It's like one that tastes like vomit. Rotten feet.
Be like boiled egg, boiled milk, or
Whoever did that is amazing. Hey, let's go back to class. Let's come back to a land called advanced pre-calculus. Shiv's here. Yes. Shiv may not study for midterms, but he's always present, yes. Okay, would you please discuss with your neighbor? Are these equivalent statements? This is the first part of 3.10.
Those are equivalent. I would say yeah.
Yes?
Yeah.
They're not
Oh,
equivalent.
he said thank you.
Like,
That's super easy.
No. Can't know. Can't be.
I'll take it down. Are they?
They can.
That's what he was.
They can be because kind of. No.
On side 5 or 6.
I have to be fairly confident. What are you talking about?
Like, I don't-
About 10 more seconds.
I want to live
5 seconds. We're just gonna talk about this so far.
Yeah.
Okay, so what do you think? Yes or no? Are they the same? Are they the same?
That's wonderful.
No.
Are we good? They're the same? Kinda. Who'd like to speak to why they think that they're the same or why they're different? And I would like to hear, so which means I want to hear only from one person. I saw Jonas's hand up first, and then I'd like to hear from Augie if he has something else. So Jonas, yes.
So they're similar in the way that, both equation 1 and equation 2, I think, yeah, sorry. Let me try that one. So they're similar in the way that it's basically equation 2 saying, for what angle does, sine of x equal 1/2? And then that's saying what is sine of x. So they are kind of similar, but in some way, but since you have to restrict the equation of number 2, that leaves out one of the answers that you can be put into equation 1. So I think equation 1 you can put in both pi over 6 and also pi over 6, whereas in equation 2 you can only get pi over 6.
So you're saying that they are the same or they're different?
They're slightly different.
Okay. Okay.
Wait.
Okay. Oh, wait, I hear some controversy. So Augie, then Max, that's some good insight. I appreciate that. Yes,
I
Augie.
was gonna say, yeah, Jonas is decidedly extremely smart. I mean, I won't change what I was gonna say based off of that, but I agree with that. That seems pretty strong with saying. I was saying, I think that they're equivalent because since that function's just the inverse of the other function, and then all you've done is switch the place of the input and the output, which is definitionally what an inverse function is. So
Okay.
that's why I think they're.
Okay. That makes sense. Max, you have something to add to that?
At first, I was a non-believer, but then I converted. I
Wow.
gotta say. So.
From what to what? Same to different or different to same?
I went from not the same to the same.
Okay.
So what I did was I said sine of what equals 1/2. So I was looking for an x value where,
And is that equation 1?
yeah,
Okay.
I was like looking for an x value where if I put it in, then
Uh-huh.
the sign would end up equaling 1/2. So I realized that x for equation 1 is √3/2. And then for equation 2, I was looking for,
√3/2?
yeah. Oh, no. Did I do it wrong?
I think we know what you mean.
Wait.
It's a,
Pi over 6.
a pi over 6.
It's pi over 6.
5 and 6. For equation 1.
Wait. I think my whole thing falls apart.
Wait, I actually don't know.
I'd like to see you be a lawyer. Actually, he's guilty.
Maybe we could disregard my.
So what do you think now?
What do I think now? Well, originally I thought x equaled.
No, now. I want to know what you think now.
Oh, right now?
Yeah.
I think that, I still think that they're the same.
Okay.
I just, no, they're different.
Wait.
No, he's innocent. No, he's guilty. Thank you. We'll hear from Emma, then Elle. Oh, interesting. Okay.
Flip it, it like becomes the same equation in a way.
Okay. Log versus. Okay.
Like the exponent and like the number and then it becomes the same thing. But it's interesting that it's both cases. Like equation 2 has two possibilities. Oh, wait, no.
He's guilty. No, he's.
The domain of, like sine first is only like this part, the part 1 and 4.
Okay.
And so the extra is
Okay. Thank you. We do have a class to teach, and this is the first of the day, so I'm gonna go with Elle and then Nia, if you still have more to say about this. So yes, Elle.
One variable, so the variable and 1/2, and then it's the same thing, except for switching for equation 2.
Okay.
The restriction on the inverse function, so if there's a solution that is outside of that.
Oh, nicely said. Okay, so they're the same, but not quite. It seems. Okay, that seems to be a kind of general consensus. Nia, do you have anything to add to that, or? And I love how you brought in the one-to-one, because I was thinking that when Emma was making her argument with the log and exponential, because those are inverses and it always works. But for both of those, log and exponential, both of those functions are one-to-one. Is sine one-to-one? No, that's why we had to restrict it. That's why we had to restrict it. So if we look at equation one, I'm going to wrap this up. I'm sorry. Equation 1, x represents an angle, doesn't it? And just asking the sine of which angle equals 1/2, isn't it? Isn't that what it's asking, the sine of which angle equals 1/2? And how many angles qualify? Infinitely many. Equation 2, when you see the inverse, it's asking about the angle whose sine is 1/2, or the coordinate, the y coordinate specifically. So is this infinitely many? No, sine inverse only happens from -pi/2 to pi/2. There's only one answer. There's two places it could be, but I think there's only one answer to this.
Pi over 6.
Oh, no, because it can't go forward.
It can't go forward.
Wait.
So they're related, but they're definitely not the same because of that whole one-to-one thing. This is like infinity to one.
They're not the same.
They're not the same. They're related, but they are not the same.
Jonas is right.
Like cousins, yeah. Like fraternal twins.
Same?
Not the same, but related. Closely related. Yeah, I think everyone was basically on the right track.
But I don't know, I thought that was that reason.
So this one has one value of x. This one has infinitely many. Yes. Uh-huh. Coterminal. Oh, that's what you meant. Okay. Now we already answered questions like these yesterday, but I'd like you to go ahead and see what you could do for example 1.
Find all solutions.
There.
I thought. Small friends.
Oh, you have to do the equation.
Okay, which means two. Right? It's 35 over 4.
Plus 5.
Oh, yeah. Wait, no, 2 pi. Yeah, that's yeah, shit. Look at that.
Check with your neighbor.
There, and, oh, there, that's good.
I got,
Wait, yeah, because you're gonna also be here. That's
Wait.
right. So then what would it be? Wait, isn't there just one solution? Oh, wait. The side is also here. Oh, it's not inverse. It's not inverse. I feel like do I hit it now? Wait, because it's like.
Yeah, that's
X
right.
here,
Wait,
and then
don't
X
hit the
across
box.
that, and then or is that- That's not higher.
Oh, yeah, you're right.
Then it's not.
Wait, are you sure about that?
I'm sure.
I'm just. I'm sure that it's two equations.
Two solutions?
With like restrictions on where they are.
That's what you and Lee are discussing, right? Oh yeah, don't forget Emma's in your little group today.
What are you?
You ready?
Wait, I
5 seconds.
Yeah.
Okay, folks, I'd like to hear from Augie. What do you think about this one? Did you were able to solve it? Yeah.
Okay, so I got 3 pi over 4 plus 2 pi, I guess, whatever, k. And then 5 pi over 4 plus 2 pi k.
And can you tell me where these 3 pi over 4 and 5 pi over 4 came from?
Sure. So, basically, it's, you know that cosine relates to it's x over root 1. So, or x over r. So then you want an x value that is negative 2 over 2, which is gonna be, yeah, the middle point of the quadrant 2 and quadrant 3.
Perfect. Are we good with that?
I have a question. And then coterminal angles because of the 2 pi.
Very nice. Simran and then Max.
If there's the, like, for example, 3 pi over 4 and 5.
Well, we want all solutions, right? We want every single solution, and we recognize that this is just one of them. Right, we need to complete. Are we okay with the 2 plus 2 pi k? Yeah, Max?
Oh, I was confused. So like for this one, you didn't need to do the inverse.
I didn't need any inverse here.
So it has to go all the way around.
We're good? Oh, that's a good question. Could we do negative 3 pi over 4? That'd be fine. If k is negative 1, that would give you negative 3 pi over 4. Nice. You're right. You just have to label that place. Any name is fine, as long as it's correct. Example 3, please. Let's skip right to 3.
Yes.
Augie, you have the answer already? Is that what's going on?
Yeah.
Don't see 2? I don't want to get the answer. I'm just wondering. Anyone else already finished example 3? Yeah, let's give everyone else about 20 seconds to catch up.
You not asking a question?
Yeah, except, you know, was it when you?
Okay, folks. I like to see the answers from everybody. Can you show me the places on the unit circle if it's true? Use a big unit circle around you. Like, is it here? Is it here? Just show me. Just you could do this or... It's quadrant 1. So let me do this. So like right there. And are we good with that?
Yeah.
So x is equal to the first angle we'll use is mx. Thank you. Pi over 6, and then add pi k to that.
Oh, that makes sense.
Okay. Let's do one more.
Oh, negative. And you can just go halfway around. No, quadrant 3.
Example 3b. Please solve this equation. Cosine of x is equal to negative 0.2. What's that? It's close to Pearson.
There was a negative 0.2 on the person.
Was it? What was the sign of that?
I don't remember. I just remember seeing negative. First thing I was like, what's that?
Good recall.
Mr. Liebman, is it not 7?
Yes, it is.
It's not example. Wait, how come? Oh, you.
Oh, X over R, X over R, and then it's like the triangle. Oh, wait, it's not actually, this is in X, okay. X is negative, wait, what? What? But and the radius.
I'm saying X needs to be 0.2.
I swear it is, I swear it is triangle. Plus X squared equals 5 squared. Plus X. So I'm investing my girl Leah. Wait, this literally just told me about it. I'm
Okay, guys. Why having difficulty with this? Because it's hard. What makes this hard?
There's no like angle.
There's no angle?
Well, it's an angle, but not one that's familiar.
Not a familiar angle, correct? Like if it's negative 1/2, you'd be done like 3 years ago. If it's negative root 3 over 2, it'd not be a problem. Negative 0.2, that's not a standard place on the circle, but we could see it, can't we? I'm going to look at the two angles that have a what x value or y value of negative 0.2. X value, it's cosine. So does that appear to be about negative 0.2? So do you see the two angles? Do you see the two angles that have that x value? Go ahead and draw them. Yeah, the two angles that have that x value. This is a unit circle.
Wait, since that's like negative 0.2 squared plus the cosine of x squared equals 1 squared, is that one?
I'm not sure that helps. We're looking for the angle. That'd be finding another side.
Like this.
Yeah, I got it.
Okay, so the first angle. Could you go ahead and show me the first angle? Just with your pen or pencil?
And then this.
Isn't it this right here? Isn't that the angle? I could have made that straighter for sure. But it's just the angle that has that x value. Right, so this is the angle we're looking for. I'll put an X there. Isn't that what it's saying? That's one of the angles. Where's the other angle?
Like the.
Show me where the other angle is. Directly
Directly below.
below it. It says the other angle with that same, right? I'm just looking for the angle that has that X coordinate. We don't know what that angle is because that's not a standard place on your circle, but they exist. The question is, how do you find them, right? So those are the two angles. Any idea how to figure out what that angle is?
Uh,
About the value is 0.2, and that's the radius is, like, could just be 1.
True.
And then
The radius is 1.
you have like A, you could do A squared plus X squared equals M squared, which is 4.
That's true. You could. You could do that.
just feel like a different thing.
Would be, you know,
Yeah, I don't think we need y. I want the angle. Like if this were asking me for maybe the sine inverse or something like, then I think I'd have to do something like that. Need to find the other side. But to solve for x, I think Max, you're onto something. We have to use a calculator. You can't do this without a calculator. But what button would you need to solve this? Oh wait. Well, let's start with before the negative. Let's start with, does it make sense that this is just asking literally for this?
Yeah.
Remember, this means the angle whose cosine is negative 0.2. Angle whose cosine is negative 0.2. Did you?
Fortunately, yeah.
Oh, so that sounds like fun. Oh, hope you have fun on your date.
I don't have to take a next.
It should. The way to check it, turn it on. And see that when it glows orange around it, then know it's. And if it doesn't, you have to adjust this a little bit. Okay, so you can let it go. No, okay. So the angle is 1.77. Can I get one more digit? 1.772. Did we all get this? If you have your calculator? Cosine inverse of 0. Cosine inverse of negative 0.2. Are you in radian? Are you in degree mode or radian mode? Okay,
Wait, so there'll be error.
did we all get that negative? Did we get the negative, sorry, the positive 1.772? I need you to find the other angle, please.
Other angle.
Oh, and why does negative, so why does 1.772 make sense?
Because.
Yeah, we know that this is 3.14-ish, so half of that would be 1.57. So I hope it makes sense to just pass at 1.57. 1.77 makes sense. Well, what's half of 3? Okay, but you're looking for the other angle.
Oh my God, it's the opposite number. It's 1.17 minus. Like it's negative. Just go like that. Wait, let me try it. Wait, so, oh, you're right. That.
With this actually.
Okay, so did you get it?
3.34.
Is it negative 1.77?
Max, what did you do to get that?
I did the cosine inverse
We
cosine.
already have the 1.772.
I took 1.77 and then I added in parentheses pi over 2.
You added pi
Because
over 2.
Pi over 2 is like flipping into the other side. It's like adding like. Should I have added it by pi?
Are you high?
Wait, hold on. I should have added by pi.
So adding pi would get you over here, right?
Oh, wait.
Wouldn't it?
Wait, maybe what I should have.
Why can't you do negative?
Isn't
Yeah.
it 3.14?
Yeah, what's your idea?
Said, well, look, Shiv, it's going that way, like how.
So we could do this.
Yeah, I went clockwise and I thought, well, let me try to put in cosine of negative 1.772
Oh,
and it rounds up to negative 0.
does that make sense, folks, that this is negative 1.772?
Yeah. Wait.
Yeah.
That means like.
Nothing but thought.
Yeah.
One of those shots.
It's the same angle, just going different directions.
Oh, so you just use the.
Yeah.
Oh my gosh.
Nice, yeah.
Throwing shots.
That was great.
Keep putting it.
Okay. Any questions? Okay, so this is. Oh, so we have this and negative 1.772. Oh, but plus we have, for both of these, actually, we should say plus 2 pi k. So I'm going to separate them. Approximately negative 1.772 plus 2 pi k. Oh, if it doesn't specify, then I want all the answers. It doesn't specify here. So this is what I'm looking for. Okay, so this is just the tip of the iceberg in something called solving in trigonometric equations, where the step 1 is to isolate the trig function. Then you find the corresponding angles, consider domain restrictions, and write the solutions and or the general solution. So this one, step 1, divide. How did you know that you're supposed to divide by 6? Isolate the trig function. So we have sine of theta is equal to root 2 over 2. Is this a difficult problem? Well, it was 3 pi over 2, 3 root 2 over 6, and that simplifies.
Pi over 4.
Is that right? Really?
Way
Are you sure?
Or 3 pi.
Pi over 4.
Or 3 pi.
Okay, almost 3 pi.
So pi over 4 is what I heard. Pi over 4 or what was
Plus 2 pi.
plus 2 pi k. 3 pi over 4?
Plus 2 pi. Oh my god. It's quick, it's quick. It just takes a few times and then you finally get it.
Wow.
Next time, let's do an example 5 over popcorn.
This one was pretty easy because it was a common space place in a circle. The last one with that negative 0.2 was just weird. Okay, this one we are trying to find where these two functions intersect, which means we take the two functions and set them equal to one another. 3 plus 2 cosine x is equal to 2. I'll give you a moment to finish it.
There's the rings, right? Oh, we got it. Cosine of x is like negative 1.
Oh, yeah.
But like this one, oh wait, it's these two. Oh, she's got it. Shit. Something
Something else.
No, wait, it's 2 pi over 6.
Is that right?
Same person.
Okay, I want to know your thoughts are Shiv. What do I do?
So we have to subtract 3, right?
Okay,
Both sides.
thank you for not adding 3 plus 2.
That was bad.
Yeah, that'd be awful. Okay. You just said 3 plus 2.
Then and.
Oh, no. Okay. Okay. So you get cosine of x equals negative 1/2. I know it's toughy.
It is tough. I got 2 pi over 3.
So x equals 2 pi over 3.
Yeah.
Should I do plus 2 pi k?
No.
In the domain.
Yeah, it tells you to keep it just from 0 to 2 pi. Okay, so 2 pi over 3 and
4 pi.
Shiv, do you agree 4 pi over 3? And those numbers come from unit circle. Can we just take a moment to appreciate the unit circle and how understanding it really leads to so much information? What's that? You can, but this is saying specifically just keep it between 0 and 2 pi. So it doesn't want you to keep going around and around and around.
I think I understand.
You get it? What helps? Involve me, yeah.
Okay. Yeah, that's kind of education. It's just, it works that way.
That's the way.
Ah, top of the next page. If you have sine of x times sine of x, of course, another way to write that would be. Would this make sense like this?
No.
No, we'd have to make it clear, right? Like that. Stop talking. You guys, stop talking. I hope it makes sense that these are equivalent. To make things efficient, mathematicians have agreed they don't want to use the parentheses though. So instead of using the parentheses around the square there, they rewrite it as sine x squared. Do you think that's what they do? The problem with this is it looks like just x is being squared. Right? That actually looks like x is being squared. I wouldn't even say ambiguous. So that square goes right here. So when you see that square above a sine, cosine, or tangent, it just means that the full sine, cosine, or tangent is being squared. This is not equal to sine times sine of x. Saying that, yeah, there's multiple problems with that. Like you don't understand what sine is at all. So I can erase that. Okay, so which leads us to lots of other types of equations. I'll give you time to do example 6.
I understand it now. Wait, you know, I'm not. Right. No, that was supposed to be first, I feel like. Max, I thought you understood it at this point. But I'm not taking it up on right? Oh, you're at this point. Okay, great. So I'm sorry. Because no, I'm going to back to the
I'm calling someone in about 30 seconds.
Okay, then X. I love that.
You love math?
I do.
Oh, you spirit.
5 over 3.
Yeah.
And then I call it, and then it's. I'm not scared of it yet. And that, I'll do another.
Oh,
Yeah. You make like.
okay, folks. Talking time is over. I want to hear what you've come to so far. So please turn to your own desk. Turn to your own desk. I want to hear from only Lee. Lee, can you help me with this one, please?
Yeah, so I started off doing was I subtracted 3 and then
But what's the equation that you're subtracting from?
from 3 minus 4 sine x squared.
Sine squared of x. So do you set that equal to something? Equals 0. Are we good with that as a start? Okay, keep on going. Sorry to interrupt.
I took 3 and I divided by -4.
Okay, give me you sine squared of x. I like it.
Uh,
Okay.
then it goes that value, and I got pi over 3.
You got what over? Sorry. Pi over
pi over 3.
3 and 2 pi over 3. Are we good with this?
No.
Why are you saying 4 pi over 3? 5 pi. This is just equals. Oh, it should be plus or minus. Is this true?
It should be plus or minus.
So when you take the square roots, it's got to be plus or minus. Is that true? Yes, so plus or minus. So that's going to open this up to a few other questions or a few other answers. Yes. It comes from just x squared equals 9, right? You don't just get x equals 3 just from understanding what's going on. That when you square that negative, it also results in a positive, so you have to consider both. Yes, if you start with a square root, it's only talking about the positive square roots. But like here, I hope it makes sense that if I square either positive or negative square root of 3 over 2, it will result in 3 over 4. Yes, Simran? Uh-huh. It depends. This question is asking specifically for 0 to 2 pi, so negative doesn't fit. Yeah. And if it didn't specify that, I would expect plus 2 pi k on all of these, or some version of that. Yeah, so Lee, you're right there. That plus or minus thing. You won't forget that on the quiz.
I'll get him next time, guys.
You will. Oh, look at that example 7. I'll give you a moment to work on that. Be careful. Don't fall for the common error.
It's so far in.
So you work on it with your neighbor if you like.
Yeah, no, man, that's it. You understand what you were saying? Sounds good. I know.
Oh my gosh, I got it. I got it. Explain. Wait, we have to divide it. Break it up. No, but the thing to do. On that side is possible. On that
So that's so like.
Then it's a no, that's why we just assuming that like they kind of go here like. You're gonna do it.
Okay, we ready?
Yeah, because. No, it.
What is posted?
I think
Okay, folks.
What is the quadrants to?
Ready or not? Ready or not? I want to just hear from someone. How do you do this problem?
Oh my gosh, I know.
Someone who hasn't given us an answer yet gets first priority. Who'd like to tell us about this one?
Thanks.
You're not raising your hand, are you? Are you? Yeah, yeah, Kayla.
Divided cosine theta on both sides.
Okay.
So I got cosine of theta equals 54.
So you got cosine of theta equals -1. Okay. And you got that from. Nice. Perfect. Are we okay with that?
Yeah.
Okay, we got Judy and then me. Yeah, Judy. Uh-oh. Because what? Oh. Yeah, be careful about dividing by variables. Yeah. So what's another option? Judy, what's another option? So you added cosine theta?
That.
Okay, but now what? So you can just factor out cosine theta plus,
So cosine theta equals 0 or cosine theta equals.
Oh my god.
or cosine theta. Ah, so it's similar. Is this what you had to?
Just
Okay.
Last, either or last.
That's the.
So for cosine theta equals 0, that happens when theta equals. Cosine is equal to 0 when theta is equal to 5/2, 3π/2. And then we already 3π/2, excuse me. And we already have our cosine theta is equal to -1, right? So that one is pi. Are there others? But is 0 a solution?
Yeah. Like five.
Yeah, it does work. So this is it. That's called ZPP. This is cosine theta plus 1 equals 0. Right. This is equal to 0, or this is equal to 0. That's ZPP. So we just want to step into it. Good catch, Judy. Okay. Any other questions? Okay, I've upped the last one. I've changed it a little bit. And when I say a little bit, that's a huge change. So f of x is equal to 3 sine squared x minus 5 sine of x. And g of x is simpler. It's just equal to 2. Let's see if you can solve this one.
That changes the whole.
I changed it. You read that? All right. So 3.
What?
You can't divide by it.
I don't know if that works. Wait, no, it's not.
Oh, I see.
Well, I don't have.
Oh. Hey,
That's not it.
No, I
Okay.
see 3 sine x
Two or
minus 5.
That's a 2. Oh, thank you. I gotta cross off x too. You're right. Just a 2.
Oh my god.
Might be stupid, but it's.
Then do you like?
Nothing's.
I got it.
Thank you, Simran, for reminding us of that.
Okay. You're back, you have some. You're right, you were 7. Oh, okay. Okay.
Okay, how do you find out time squared? Oh, it's
Fine. Then I would have bought it too.
Have you put a zero in your equation yet? No.
It's not square. It's not
I'm trying to get a zero before factoring.
God, you tell me that.
Wait, sign of X.
Oh my god, I did it. I did sign of X to 0 and 3 times. Oh my
So
god. I'm cooking. Never once.
I got one of them.
Did someone turn up the heat in here? What happened?
Like, how do you solve that?
How do you try to make it?
So I would
Wait,
back
two
up
answers
to
are
nine.
two.
Wait, I think we got it usually.
Yeah.
Two of the answers.
Oh my god.
Hey, Mr. Lieberman, two of the answers.
Wait,
More, but
no,
power
yeah,
makes
I
power two,
got-
right?
So.
I don't know. I don't know.
That's gonna be the same. We don't have this.
Back up here. So
Yeah, what
sine
did you
to the
do?
x squared, so I factor out the sine of x.
Wait.
I'm factoring sine of x. It's equals.
What?
I factored it out. Because it's a sine of x.
You can calculate.
Because I factor sine of x, I feel it's not. Because sine is 2x, so sine of x. Factor out.
What got it? Oh,
If you guys raise your hands, I'm actually like on my soul.
Oh,
On my soul. Like,
10 seconds.
Yeah. Oh my god, that's it.
Okay. I'd like silence while we're helped by one person, just one person, who could talk us through as much as they feel comfortable with, and hopefully till the end of this, or pretty close to the end. Who would like to help us through this problem? Okay, Jonas, yes.
So if you write it out, just write it out as just write it out.
Okay, b sine squared x. Okay.
Equals 2.
Should I actually say equals to?
Well, you can say -2 and then equals 0, and then I can turn it into a quadratic. You can substitute sine of x into a, and you can get 3a squared minus 5a minus 2 equals 0.
So 3a squared minus 5a minus 2, like this?
Yeah,
And why did you do that substitution?
it's much easier to solve it as really quadratic.
Okay.
And then if you factor that out, you should get 3a plus 1 and a minus 2.
Is this true? Does that work?
That's fine.
Okay.
And then you get sine of x is equal to 2 and sine of x is equal to 1/3.
Okay, so I guess from here we get a equals -1/3 and a equals 2. So from there, you're saying we could just say sine of x equals -1/3 and sine of x equals 2. Are we okay with this, folks?
I am, but I'm here.
Yeah, from here. One of these is,
Impossible.
why is it impossible? Wait, actually, when you check with your neighbor, why is one of these impossible?
But aren't they this?
Negative 1 and it's out of the range.
No.
She right.
It's
You're right, you're right.
So it's negative 1/3.
That's why I kept getting errors.
Yeah.
Yeah, so the problem is the 2, isn't it? Isn't that a big problem?
Yeah.
Why is that a problem? Like, do we need a calculator to know that's a problem?
No,
No.
oh, you got it.
You know from the unit circle that sine goes up to 1 and down to negative. There's nowhere where sine is equal to 2. Not helpful. So we just dismiss it. And that's okay. But sine of x equals -1/3. How are we supposed to do that?
Calculator.
Calculator. You need a calculator. To get one of the values, you're going to say x is equal to
Negative 0,
Negative
0.3
1, negative.
sine
0.3 340.
inverse of negative 1/3. Is that clear?
Yeah.
I'll show you the range. Sorry, it's been. Like I said,
So the two angles are here, and you see where the other angle is? Which angle is your calculator going to give you? The one that's in the fourth quadrant. Yeah. So what do we get here for x? 0.40 340. Do we agree? What's the other one? Is it positive 0.3? Discuss. What's the other one? And we see it's over here.
It's not in the range, so you get that. There's only one answer.
No, there's. Remember, this is the question. This is the question. There's point one.
But like, didn't sign it written on.
Yeah.
I was just looking at this.
Thanks for
Yeah.
I'm gonna take my win. I didn't have any left.
Oh, it's pi plus pi plus 0. Yeah, stop. Oh, wait, the data's talking about negative.
The other one. That's a.
Yeah.
I'm concerned that there's a general lack of focus kind of through the day for many of you. So I need you to dial it in a little bit. I need to know what this other angle is because I know that first one, the fourth quadrant, is negative 0.340. Did you already figure out the other one? Yes, Neil. Would that make sense? Pi plus is 0.340.
I figured it would.
Would it make sense?
I looked at it. Wait.
What do we want? 8 plus 0.
Well, if you're in degrees, but remember the 0.3 is already in radians. Well, this here is pi, and this angle here is 0.340, isn't it?
Yeah.
Yeah, so pi plus 3.340. Which is I don't know what that is, but it's that. Yeah, that's exactly what it is. Don't you see it? Or visually it's sound, I hope. Okay. So wow, that was a big day. That was a big day. Good catch on that end. Should I add 2 pi k to any of this? Why not? Yeah, it's just asking for this. Okay, folks. Time sure flies, doesn't it? Great job today. Next time, maybe we'll have a little bit of this on the quiz. Quiz next time. Have a great day, folks. I'll see you on Thursday.
I could.